Hey guys, today I want to talk to you guys about IP addresses and subnetting them. So what is an IP address? IP address is basically, you can think of it like your regular home address. It tells machines where other machines are located. So it tells servers where we are located, and it tells us where certain servers are located. It's what we use to access servers and their services. So usually, so there's two kinds of IP address. There's the IPv4, which is written out like this. One, it has four sections. It has like four sections, and each section it goes up to a number up to 254. So it can be 0.0.0 all the way up to 255.255.255.255. And there's also the IP. I'm sorry, I said 254 before. It actually goes up to 255 IP addresses. And there's also the IPv6 address, which is it doesn't use numbers. Instead, it uses what's called hexadecimal. So it goes up to like XXXX to XXXX to XXXX to XXXX to XXXX to XXXX. And what these X's are, it's hexadecimals. And I'll get into that later, but first I'll talk to you guys about understanding the IPv4 addresses. So IPv4 addresses. What does this? Why does it go up to 255? That's because it's represented by 8 bits. So each zero is a byte. Each zero is a byte here. Each section, and each section is a byte is represented by 8 bits. So what that means is you gotta understand binaries. So what are binaries? How many zeros is that? Let me just get off 8 zeros. So each section is represented by these 8 bits, and these 8 bits, you call them a byte. And how these work is, if you turn each one of them on, if you turn on the first one, it will be 1. If you turn on the other one, it will be 2. So what I mean by that is, so these bits, these are like legit bits in your computers. And how computer read information is they read these bits if this bits is turned on, or if this bits is turned off. And you can combine these things together to like represent a lot of different kind of informations, and that's how basically computer works. Just looking at bits and bytes, if it's turned on or is it turned off. And so in IPv4, if it's turned on, it means if the first bit is turned on, it means 1. If the second bit is turned on, it means 2. If the third bit is turned on, it means 4. So 4, right? And it just keeps on multiplying. If the 4th bit's turned on, it's 8. And it goes all the way up to 128, right? So it goes from 128 to 64, 32, 16, 8, 4, 2, and 1. And if you add all these together, you get 255, right? And if, for example, if you want to represent an IPv4 address, that's like 128.92.8.2. you would represent it like this. So the first one, you would just turn 128 on. So this one. And for everything else, you would just put 0. And for the second one, 92, you would just turn on 64 and 32 and leave everything 0. For 8, you would just turn on the 8 and leave everything as 0. So that's how IPv4 addresses work, and that's how they're represented in bytes. And it's a pretty big number, like how many different kinds of addresses you can represent with this, and it's actually up to 4 billion. That sounds like a really large number, but when you put like things into perspective, it's actually not, and we've actually ran out of IPv4 addresses, and that's why we created a new one, IPv6 addresses. But before I talk about IPv6 addresses, I got to talk about subnets. So what are subnets? So usually, after like you represent a number in IPv4, right? You would put like 128.124.12.24/24. I'm sorry, 25, and then you have a /24 in the back. Oops, sorry. And what that number represents is actually subnets. So different. I won't go into that much detail in this video. I'll just talk about IP address. I'll make a separate video later on. But it just represents. You can think of it as like segmenting houses by blocks. To cross the block, to go to the house on the other side of the block, you will have to walk there, but you can't cross it without walking over the block, right? It's kind of the same idea here. You're segmenting the networks. You're segmenting the IP addresses, and the IP addresses can't talk to each other on the IP address on separate subnets. They can't talk to each other unless they're using a router or something. So and the /24, it's whatever's in the back, it's actually represented by how many bits are turned on. So just like the IPv4 addresses, the subnets, it's also represented like this. And when you have a /24 here, it means these 3 bits, they're all turned on, because each bit is 8 bytes, right? And this is 24 bytes, and 24 divided by 8 is 3. So it's these 3 sections, the first 3 sections. So what that means is if you only if you're the IP address, IPv4 address, if only you can only talk to each other if the first 3 octet is the same. So there's a /24 here, right? And so that represents 3 octets. And so that would represent, if you have if there these 3 will be your subnet. That would be like your subnet. And everything in the back, that would be your host ID. And so subnets, it's basically just segmenting your networks. And there's also subnets in IPv6 addresses. But so remember how I said IPv6 addresses, they're represented by hexadecimals. So that means they go up to 0 to 9. And then it also goes up to A, B, C, D, E, and F. IPv6 addresses, it can have like 0 to 9, any number. So each of these X represents whatever these are. So it can be a number from 0 to 9 in A, B, C, D, E, F. And what these A, B, C, D, E, F actually represents is A represents a 10, B represents 11, C represents 12, D represents a 13, and so on. And these X's, they will represent or whatever hexadecimal you choose. So XXX, and there are 6 different sections or objects, and just like IPv4, there are subnets in IPv6, but the subnets works a little different. So this one is actually a subnet that's provided to you by the IANA. So it's the Internet Assigned Numbers Authority. So it assigns your subnet. And then this one is specific for your region, and it's assigned by the RIR, or the Regional Internet Registry. And the third one, it's provided by your ISP, so Internet Service Provider. And I'm sorry, I actually made a mistake here. This actually 8. I'm sorry, I don't know why I said 6. There's actually 8 different sections in IPv6. And then the last one, last subnet, is the subnet that you want, that you choose. And each different numbers will be a different subnet. So if the X is a 1, it will be a different subnet. If an X is a 2, it will be a different subnet. And everything else will be your host IDs. And that's basically it for the IPv4 and IPv6 addresses. In the next video, I'll talk more about subnetting and how it really works.